Hello, everybody, and welcome to the Energy Management with InduSoft Web Studio and the University of Texas webinar. So first of all, I'd like to start the presentation today by thanking our clients, our customers, each one of you for this past 15 years of support. It's only because of this support that we are able to keep evolving our product with innovation, success, adding new features, and we'll be talking a little bit more about some new exciting features that we are adding to our software on our newest releases. So it's really just want to take the time to thank each one of our customers and partners for this 15 years of success. So on the agenda for today, my name is Paulo Guerra, and I work with the consulting services teams for InduSoft. Pretty much this department, we work together with customers using our platform, the InduSoft Web Studio, develop, design their application to meet their requirements. And that's exactly how we built this energy portal for the University of Texas. So today I will be doing the demo after Roberto's presentation, so you'll be seeing a live demo of the energy management portal, and then I'll be talking about some of the key features, some of the key functionalities from InduSoft Web Studio that were used in order to accomplish this project. As I mentioned, I have Roberto Del Real. He's the Associate Director for the Utilities and Energy Management Group at the University of Texas in Austin. I really want to take the time to thank him for taking the time to be here today and putting together this presentation, as well as for this partnership that we established over the years. It's been a really great pleasure to work with his group on this solution. And Roberto will be talking a little bit today about the work that his group does at the University of Texas, some of the challenges that they were facing when they designed to build this solution, as well as what they currently have nowadays in place. And as I said, after that, we'll go through a live demo, some key features, functionalities from InduSoft Web Studio, and you'll be open for a Q&A section. Really important, if you have any questions during the presentation, it's really important that you type those in at the webinar Q&A control. So if you go to the webinar control on the top of your screen, you have there the Q&A section. It's really important that you type those in there. Unfortunately, we cannot listen to you guys. And at the end of the presentation, we'll both be answering as much as possible, if not all the questions. With that, I'll be passing control to Roberto Del Real. Roberto, thank you again for taking the time to be here with us today.
So we'll go ahead and give you a little bit of background of what we do. We have as you may know, we're one of the largest campuses around the nation. We proud ourselves to be one of the world top universities in terms of academic and research. The university, so everybody knows, has approximately 51,000 students. We have 24,000 faculty and staff combined, and we have build base around 17 million square feet. We cover 350 acres, and we have 200 plus buildings. We generate power with our own power generation equipment machinery, and we picked in the summers at 69 megawatts, which equates to 350 million kW a year. We have also showing stations producing chill water for campus cooling, and we pick around 35,000 tons of cooling, chill water cooling. We generate our own steam for campus heating and research labs. And we can, in the winter, we also picked around 220,000 pounds of steam, pounds per hour of steam. We generate, we produce deionized water for both our boiler field makeup and laboratories around campus, and we also produce our own compressed air. So we, as I mentioned, we're known for quality of education and research. And to maintain these very high standards of education, the interrupted and cost-effective as well as efficient delivery of energy plays a very important role. as a response to that, we in our department, we decided to adopt a comprehensive and innovative solution for energy measurement and energy analysis, both in supply and demand areas. This solution is inclusive to all campus energy systems and was developed with the main objective of presenting different sources of data in an easy-to-use interface. Talk about a little bit about our group. Our group is composed of process control programmers, instrument technicians, electricians, building automation technicians, energy engineers, and behavioral-based energy stewards. The control programmers pretty much do small to medium-sized projects, and this is one of their projects. They've been able to do all the networking necessary to segment our networks in a secure way and to transfer data to and from the different data sources and what is needed. We have a set of around 10 instrument technicians that take care of the day-to-day issues in the plants. We have a total of 4 showing stations in main campus and 2 remote showing stations around 10 miles away from main campus. We have a very strong calibration program, and these instrument technicians take care of that. They also take care of all the energy meters around campus, which amount to close to 900 energy meters, both thermal and electrical meters. We have a set of electricians that do most of our electrical installations throughout the power plant and the showing stations. These installations have been evolving, and we try to use latest technology, and so they contribute a lot for this endeavor as far as the energy development, the energy dashboard, and where the data is coming from, the actual field devices installation. We have automation technicians for the buildings, a couple of 3 guys that are always looking at how those buildings operate. We have a set of energy engineers, and they're always coming out with energy conservation measures to lower and improve lower the energy use, improve the efficiency of the buildings, and optimize them. We also have a set of persons that do nothing but talk to public about the campus community about the behavior in terms of how they affect the energy use. It's been very impactful, and we have obtained pretty good results with these many groups that we have within our department. We had, to give you a little bit of background, back in 2005, there was an initiative of instrumenting the campus and automate the campus metering. We had a challenge back then, and we needed to turn the existing mechanical meters into pseudo-smart meters. We wanted to eliminate the manual meter readings, which, by the way, used to take close to 2 weeks for a person to go around these many buildings and take readings the first 2 weeks of the month. Then there were errors produced by the data entry into an Excel sheet from these manual readings. We were able to reduce, we wanted to reduce those errors. We also wanted to eliminate the 2-month billing delay from reading meter to bill creation. So our goals were make metering and billing maintainable, provide campus users real-time and historical energy data, as well as make building energy data readily accessible for use by energy conservation programs. We had since have had additional challenges. Of course, we wanted to document and learn the campus building energy behavior and be able to analyze it was a big goal for us and a challenge. We wanted to have a challenge was that we didn't have a one-stop shop site where we can have all the campus energy related data needs. Another challenge we had was the availability of those data sources wasn't readily available. And we needed to have the ability to interface with multiple control platforms. And we'll talk about that a little. We also needed a state-of-the-art trending capabilities. More on metering, we started off, as I mentioned, in 2005, and the use of these little PLC boxes, 24 by 24 boxes, was implemented, and we brought in hardwired signals from these electric and thermal meters to include the domestic water. The steam was measured in terms of condensate. We have chill water meter, both flow and differential temperature, and we also have domestic water and electrical. We made use of the back then of the backbone semi-private network that the facilities network has available for us. This is our metering history up until 2010. We started up in 2005 with 18 buildings that were utilized by auxiliary enterprises. Auxiliary enterprises are enterprises that can be, they have a concession by the university to operate within the campus, such as cafeterias, athletics, and housing and food. And we started collecting data on the chill water meter only. In 2005, we installed our first set of PLCs and networking them all the way up into our data collector. After that, 2006, we had 20 buildings with PLC fully automated. 2006, we started gathering data by utilizing OPC technology. We utilize that technology a lot. We have been doing it from those years and even before then for our process controls. We use this data. Then the advantage of it is that OPC drivers can talk to different platforms and bring it to a centralized place. In 2007, we contracted a company to help us install 75 more of these boxes. We, of course, work with them hand in hand with our electricians and instruments, and we were very successful on finishing in 1 year the installation of 75 more boxes. In 2008, we were able to have a data collector in our old existing historian back then, and we were doing Excel queries off of this historian, providing the bill to accounting, which was now in an Excel form. In 2009, we bought a software, and we started using it at a company off of Chicago. In 2010, we were approached by InduSoft upper management in 2009 offering the software to us. The software was too good to be true, to be honest with you. So we didn't start a partnership until 2010. And in 2010, that's when we started, and we started obtaining pretty good results. InduSoft developed a more basic metering interface for us, which provided alarming capabilities when meters go down, and a great database that we can log meter issues and go back to those meter issues in the future, right? More on our metering history. Chill water, we started with just a handful in 2008, and then by 2014, we had more than 100 meters. The electric, the same, we started low, and by 2014, we had more than 300. Today, we have around 386 meters, electric ones. The steam, in 2014, we were up to more than 100 as well. In water, we have close to 200 meters. By July 2014, we had close to 800 meters, and today we have close to 900 meters. Campus continues to grow, and we're utilizing the very same technology in the new buildings. We have an initiative by the university officials, and we are currently building 1/4 more of the campus proportionally. So the campus is going to grow by around 4 million square feet. We are building a showing station and hot water plant to cool and heat that medical district. And the metering technology will be utilized as such. One of the challenges was to be able to have different control platforms coming into this energy dashboard, energy portal. The platforms that we had in the past, we ended up modifying them so that we can bring data across the networks in a secure manner. So we segmented our networks and created 2 more segments. The application network, which is the InduSoft, where the InduSoft Studio resides, and then the data network. We have the 4 networks up on top of this graphic. One is the balance of plant, which is the support PLC-based, Rockwell PLC-based infrastructure to run all the processes adjacent to power generation. Power generation is an Emerson Ovation-based DCS, distributed control system. And then we also have now segmented the Shearwater loop, which is PLC-based and is Rockwell technology. We have what we call the SCADA network, which is, in fact, an electrical distribution network. Relays for protected devices and metering within the high voltage resides on this network. All of those networks were brought in. The data from those networks segments was brought in through gateways that we installed, and after a firewall, this data is gone into our enterprise OPC, which is fully redundant. We have Kepware technology. It's an OPC manufacturer and developer, and we have LinkMaster within it. Then we firewall this data once again to go into the application network, which is where our InduSoft Web Studio resides, eDNA for billing, and Thermis web application. Thermis is a modeling, hydraulic modeling software that we own. We have, of course, data coming from servers and from controllers as well as HMIs. We then still firewall this information from the app network into the clients, the energy portal, which resides on our UTNet. So we have data from all these energy sources, The demand side, which is the facilities network, that's where our meters reside. We have a total of around 44 PLCs in balance of plant. We have a total of around 28 PLCs in the Shearwater loop, 12 controllers in the Ovation network, and close to 400 devices in the SCADA network. We have, as I mentioned, around 900 energy meters in campus. That's the demand side. So these are our network segmentation solution that we have developed. What are the remarks of this endeavor? We, after install PLCs, we reduce cost by simplifying the installation of these PLCs. We have an automated billing system which reduces errors and labor. We can identify issues with energy metering using real-time data. And now we have smart meters. Auxiliary enterprises in particular, they're calling us in to help them reduce the energy use. They've been watching it, and by them doing small changes, bringing lights off, turning the thermostat a little higher, we're able to save energy up to 15% by what we call watching the energy use. We have now around 80 to 90% of all thermal and power delivered to campus is metered. We have now a pretty strong energy analysis system, which we utilize mathematical models. We use regression analysis and normalize the energy use on a per building basis. We're able to compare buildings one against the other or sets of buildings of the same type. we have now consolidated all of our data sources. Power generation distribution is readily available to the user.
Now, as we talked on the beginning, pretty much you'll be going through a live demo. So this is their live system running at the University of Texas. So first thing, I'm going to just launch since the beginning here so we can log in. And the first thing you notice here is that we are not using Internet Explorer web browser. We are using the Chrome web browser, which means we are using our new SMA, our new thin client solution, Studio Mobile Access solution, which allows us to use any HTML5 compatible web browser. And we'll be talking more into details later today, but just want to highlight that now. So I'm going to log in here. And right on the home screen, you see this big, a nice diagram, or called a Sankey diagram, where very easily users from this portal, users from the University of Texas, can have a snapshot, pretty much an entire overview of the energy flowing real time through the campus. So the idea with a Sankey diagram is that you have these nodes, which on UTKs represent areas or processes within the campus, or even energy, a type of energy. And pretty much the lines connecting those nodes are the thickness of the line, or represents the amount of energy or amount of flow going from one node to the other. So it's a very easy way to see, for example, coming out of the boiler, and we have this amount of losses, and so on and so forth. As many of you imagine, this is not an InduSoft native object. This is an external component that we are embedded within our application through the use of a new feature that you'll be talking more today as well, called custom widgets. So pretty much the ability to host external contents within your application, within your project. So that's exactly what you are seeing here. As Roberto mentioned, we have all the areas, different areas of the campus covered on this project. So we have the generation side, the demand side, and even sustainability efforts. But today we're going to be focusing and talking about the demand side energy. So I'm going to click here, and then I'm going to be accessing this area of the portal. Once you access this area of the portal, you're always going to have this map, this nice map here on the left-hand side, where pretty much we have highlighted all the buildings, or as Roberto mentioned, close to 200 buildings that we have meters installed, that UT has meters installed, and we are making readings of them. Also below, you see the current weather. So this is a live weather information that we are receiving through the use of web services, and we are able to display there the weather, forecast, and so on and so forth. So here, normally what the user would do, the first thing he would do would be to pick a building that he wants to look at. So if I click on a building here, then I access this pop-up where pretty much I have some information, the building name, address, but also the different areas that you can access now for this building. So let's start by energy analysis, where pretty much you're going to have different screens developed to help, as Roberto said, they analyze the weather, the energy consumption through the campus. The first one is energy by building, where pretty much we are aggregating all those meters within a building and storing this data so that they can look at past data very easily, in a very easily and powerful way. So the first thing you notice here down below is this new object that we are using, what we call the navigator, where we show all the data that you have available. So pretty much, as Roberto mentioned, since 2008 here, all the way to 2016. And you can very easily navigate using this object to see different intervals, change the duration, that's what you're looking at. So a very powerful, very key state-of-the-art training capabilities. You can do change here. So for example, I could come here and change the background color, because I think it's easier for me to read data this way. I can also come here, for instance, and change the resolution. As Roberto said, we are logging this data hourly, daily, and monthly. So now I'm looking at daily. I can very easily come here and change to monthly, and then you're going to present the monthly records for this building. If you come back real quick here to daily, you see that we are displaying at the bottom the energy use, and at the top the weather use or the weather data. So pretty much we are displaying CDD, cooling degree days, and heating degree days. And the user can very easily see how, for instance, the cooling is affected by the CDD or the cooling degree days. So again, a screen for them to very easily look at the past history data, and they can even export this data to different formats, Excel files, and so on and so forth. Another screen within this area is called the deviation analysis screen. So if you go there, the idea with the deviation analysis screen is that you'll be able to look or overlap two different periods of data on top of each other. So you can compare 1 week from last year with a week from this year, for example, and see how change that they made to the building affect their energy use. And again, you can very easily see here, you have the cursor showing exactly what are the difference in values. You can change the interval that you're looking at. We can group the data. So for example, I can say I want to look at them grouped. So this way it's even easier to see one on top of each other exactly what you're looking at. The problem with whenever we are comparing energy data, as Roberto mentioned, is really what the external factors causes on the energy use, and especially weather. So depending on the weather, your consumption for cooling or heating will be affected by that. So what we've built is this baseline analysis screen here. And pretty much through the use of regression analysis, we are able to normalize the weather, the energy consumption per weather, so that we can really compare apples to apples. Because if you think you're comparing two different summers, if one summer was way hotter than the other, doesn't really mean that this summer you are using less energy, just because the weather was colder. So it was really important to build this interface so that they can really compare apples to apples. And if I come here, and I'm just going to ungroup here just so it's easier for us to look at that. What we have here is that at the center, we have the normalized consumption. So pretty much the user selects what year he wants to normalize, what year he wants to compare with. So he chooses 2014. So we, through the use of regression analysis on the fly, as the user changes the year, the building, the period, we calculate this, we normalize through the use of CDD and HDD. We normalize, calculate the normalized consumption, and we compare against the actual consumption, which we have down below here in blue. And then we have the difference on top. So anywhere where you're seeing the green marks means that UT is saving energy compared to 2014. Anywhere that you're seeing red marks means that they are less efficient than 2014. And as I said, everything is done through during the run times. Everything is done on the fly. So right now we are looking at cooling. On the sides, on the right-hand side of all these screens, you're seeing these meters, which pretty much represents the live measure for these buildings, but they also work as a navigation. So right now we are looking at the cooling. I can click on heating, and pretty much you're going to recalculate this module, recalculate this energy consumption, and compare against the actual consumption and provide a difference for the user. And again, they can export this data using, so if I come here, for example, they can come here and export now this data to a CSV file, to Excel file, and very easily provide this data to different users. Through the use of the same mechanism, the same modeling, mathematical modeling, we are doing also energy forecast. So UT partnership with a weather provider company, where pretty much you are able to receive not only this live weather information that you are displaying here at the bottom, but also history of weather and also forecast of weather. So pretty much with this weather forecasting hands and 3 weeks of real energy consumption, hourly weather consumption, so a lot of points here, we are able to find a module, find a mathematical model for this building, and then using the forecast energy, the forecast temperature, forecast the energy use. So what you're seeing here at the top, the light red line are real temperature, real weather data, and the darker line is the forecast data 7 days ahead. At the bottom, the red data is live, real data collected in the past 3 weeks, and the yellow one is forecast data based on the forecast weather. And again, they can export that, and then they can compare 1 week later to see if something that they change help them save or lose energy. Okay, so again, this is the area where users can do some advanced energy analysis on the buildings. Another area of this portal, as Robert said, actually the area that started this portal is the metering portion, where you can see the meter data, each one of the meters. So if you don't know exactly where your building is on the map here, you can go to a list, and we provide a list of all the buildings that they have on the campus being monitored nowadays. And I can come here, and now I can access the metering portion, or the metering screen, the metering screen, where pretty much are going to display all the meters we have installed for this building. And you are able to see live data, so all the variables for this meter in live mode, or you can even right-click, and we are able to open an external tool from a historian provider, what they call a quick trend, where very easily they can look at the history of that data instantaneously. So again, the ability to host external contents, external system was really important because you use different platforms. So the idea that they could tap into different platforms was really important to them. Another area that Roberto mentioned about this metering screen here, really important, was for the maintenance people, to help the maintenance people maintain all this nowadays close to 1,000 meters working in a easily and faster way. So what we've built, they can also right-click here once they have the access to that, if they are from a given group, category, they can access this screen where pretty much they're able to make notes, for example, saying, okay, we know that this meter there's a problem and we are aware of that. They can write what is the location for this meter. So if someone else needs to exchange or perform some duties on this meter, they can very easily find it. They can put serial information for these meters. So again, a way to help not only the energy people looking, the energy steward looking for the weather data, the consumption data, but also the maintenance people helping them keep this huge campus running without having to rely on papers and so on and so forth. Until this point, everything we talked here was building specific. We pretty much were looking at a specific building, looking at a specific area. Now, we also have a second portion of this portal, what we call the campus-wide portal, which pretty much are screens that they are able to visualize information from the entire campus at their hands. So, for example, I can go to the compare building here, and the idea with this screen is that the user can come here and select, for instance, an interval that they want to compare. So, for example, I want to compare yesterday. They can filter if they want to look at the chilled water, steam and flow, or just water. They can pick a building selection, a building type. So within the university, they have different building categories, as Roberto mentioned, dormitories, restaurants, research facilities. So they can pick what type of buildings they want to compare, and then they can really run this selection or run a query to pull data for this selection, and we provide a comparison of all the buildings within this category on a single screen. So what you see here on the left-hand side, this pie chart here, is the breakdown per utility for all the utility use for all these buildings together. So roughly now this time of the year, as expected, 50% of the energy used is through heating because of the cold weather. Then you have electrical and cooling. Then you also have a list of all the buildings showing what are the buildings that use most energy and least energy. And then we provide the same pie chart on the right, but this time per building. And we keep cycling through all the buildings showing, okay, for this specific building, it's using way more heating than electrical, for instance. And they can pause and play so that they can export, they can analyze the data. At the bottom, we provide these bar charts showing all the buildings within this category again, and we show the breakdown per building of all the utilities. They can also use the first pie chart as a navigation. So they can come here and say, oh, I want to look at only at heating, for instance. So they can click on heating, and we have this nice animation again showing the seamless integration between these external contents within our application. So they show this nice animation, and they update down below here the energy for only for heating. If you click electrical, same thing, you're going to show only the electrical. If I click back, then it's going to show all three, the breakdown of all three energy uses. So again, a very easy to use, seamless integration, a single website where they can have access to all the information. As we said, we are just talking about the demand side today, but through the same website, they have access to the generation side, sustainability initiatives, and so on and so forth. Okay. With that, I close the demo, the live demo here, and now let's talk a little bit about some of the key functionalities that were used in order to develop this application. So I'm going to get control back here. Okay. So out of all the challenges we had when we first started developing this project, the two big ones were really connectivity and mobility. Connectivity, because as Roberto talked and even showed up to us their diagram, University of Texas used different systems into different networks through firewall. So it was really important that the platform provide a very provide out-of-the-box connectivity to different ways, different means. And that's exactly one of the main characteristics of InduSoft Web Studio, so that was definitely something that helped us achieve this goal, and we'll be talking a little bit more about it. And the second one was mobility. As I mentioned, UT wanted, since when we first started, they knew that they wanted, once this application was available to the public, people would like to use their own smart device that they are used to use, their iPads, Android, tablets, their MacBook, not only Windows platform. So it was really important to develop this application to be mobile, to be cross-platform, to be able to access and visualize this application from the smart devices that everybody's used nowadays. Okay. Talking a little bit about connectivity. So here we have a diagram which shows all the connectivity types, or some of the connectivity that InduSoft Web Studio provides out of the box. So starting at the left corner, down corner there, we have the native drivers. So nowadays InduSoft Web Studio has more than 250 native drivers, from proprietary protocols, OnRoll, Allen Bradley, Siemens protocols, to industry protocols like Modbus, Profibus, DeviceNet. So out of the box, you have all the drivers that you need to talk to your devices, to all the industrial devices you might have on your plants, on your process. We also provide OPC. We are a member of the OPC Foundation since 1997, and we provide OPC clients not only for the classic or the DA OPC, but also for the UA, .NET, XML. So pretty much you can choose to invest to the different flavors of OPC technology, which one you want to use for your project. Web connectivity. Since day one, the idea when we first started developing the InduSoft Web Studio, the idea was that you'll be able to access your application from anywhere, not only from your computer, but also from different devices. So we always worked to have our to make our project available, to make our product available through the web. And our newest Team Client solution, the SMA solution, is the evolution of this effort. TCP/IP, OPC server, and gateway. So, for example, not only we are OPC client compliance, but we also provide OPC server. So, for this project, for instance, we are reading weather information through the use of web services, but then we are providing this weather information through our OPC server to different systems within the University of Texas campus. So, really important for this project to be able to pass information as well to other systems. Database connectivity. We have a pattern on that, and pretty much you are able to talk with any relational database, Access, Oracle, SQL Server, different historians, and that's exactly what UT needed. They have different historians, different database types that they needed to type all together in a single platform. And last, API. So if you need even broader and deeper integration between our system and your third-party systems, we also provide APIs that you can use to develop this integration, this deeper integration with your third-party system. Okay, so again, out of the box, a complete system that you provide all the connectivity that you need. And here I just put another diagram now talking specific about the UT. What are the types of connections that you are using? So we have some native driver talk with some devices. We rely a lot on the OPC technology, as Roberto mentioned, so UT use a lot OPC technology. Was really important that we supported the UA, or the Unified Architecture OPC technology, because as Roberto showed on that diagram, UT use a lot of remote OPC connections. So if you had to use remote OPC connections, rely on the VCON technology, would be really a big challenge, if not a showstopper for a project this size. So it was really important to be able to use the OPC UA technology, which make the remote connections very easily, but at the same time very secure for us. Web services and FTP clients. So as I mentioned, UT partnership with a weather provider company, where pretty much through the use of web services and FTP, we are able to download live and history data, and as well as forecast weather data that we use for different uses through the dashboard, and as I mentioned, pass through to other systems within the campus. Database connectivity. So we use SQL Server for all the analytics that you're using for the energy portion, but we are also talking with different historians that UT has on their campus. So really important to have all the database connectivity that we needed. And last, the SMA client. So of course, the team clients be very important, being able to display this portal, this application on any platform from Windows to Mac to Linux, Android, and iOS. Okay, so really important, connectivity was really one of the key features, functionalities that we needed in order to achieve this goal. The second one is really mobility, as I said. So on the beginning of the demo, I mentioned that we are using our newest team client solution, or our SMA team client, Studio Mobile Access. And what are the key benefits of this solution? First and most, it's a platform-agnostic solution, meaning that you'll be able to visualize your application from any platform. So you're no longer tied to a Microsoft platform only. And the same applies for your host, your web browser that you're using. You are not tied to Internet Explorer anymore. You can choose which web browser do you want to use, so Internet Explorer, Chrome, Safari. And the technology behind this feature is HTML5, so any web browser compliance with HTML5 can be used to visualize this application. Another big important characteristic of this solution, especially for big projects like this one, is really the lack of, that you don't need to worry about your IT, your information technology department. We no longer need about having to manage the client machines and installing add-ons on the client machines, because this solution is free of add-ons, meaning you don't need to install anything on the client machines. Everything resides on the server. So that's a huge benefit for an application like that, where you have hundreds of users accessing your application, and if you had to manage all these client stations, would be a big economical problem for the IT group. The same time that, so kind of on the same lines, at the same time that the lack of an add-on, a required add-on, the client solution is a big benefit, it also brings a challenge, because nowadays a lot of systems, platforms rely on ActiveX and .NET components, which are add-ons that you have to install on the client side in order to embed it one application into another. So that was one of the challenges we had. We were going to this new platform, but at the same time, UT wanted to have external contents embedded into their application. And through the use of HTML5, there was no technology available for that. We couldn't rely on ActiveX components and .NET components, which are widely used nowadays on the industry. So for that, InduSoft invested a lot of R&D, and we came up with this new feature, which we are calling the custom widgets, which is exactly the capability of embedded hosting external contents within your InduSoft application. And through this external content, you'll be able to access InduSoft tags and functions through properties and events, what we call. So very similar to the ActiveX components, .NET components, but is no longer based on a proprietary technology. It's based on agnostic technology. So again, it's a platform agnostic solution, a web browser agnostic solution, and the technology behind HTML5, CSS, and JavaScript. Another nice big advantage of this solution is that nowadays you can find a huge amount of information regarding or resources to use with JavaScript. So pretty much while you are creating your custom widgets, you are creating your objects, your external contents, you can choose which JavaScript library, for instance, you want to use. You are no longer tied to one specific manufacturer, to one specific software provider. So you can use jQuery, Angular, Polymer, both of them together. And then you can also find nowadays tons of resources for objects already implemented, ready to be used with very little programming, be able to host them on your application. So from general user interface objects like the jQuery UI, which provides datetime pickers, menus, tab bars, and all that already designed for the web, designed for HTML5, designed for the smart and modern devices. Through very specific libraries like HighCharts, or a very high performance charts library that we used on this project. To even more specific ones, like the one we used for the Sankey Diagram, which would be very hard to develop without an external library. So again, you have a huge amount of resources available on the internet today for you to host and make use when building these modern applications. And here I just put a slide kind of showing all types of custom widgets that we built, some of the custom widgets that we built for this project. So starting here, we have like the Sankey Diagram, as we talked, the HighCharts graphics, very high performance, seamless integration charts, the UI objects, so mobile menus, date time pickers, tab bars, being able to host external websites, like for instance, Google Maps. So again, a very powerful new feature that will allow you to embed and create a very powerful solution for your customer or for your needs. Okay, with that, I close my presentation here about some of the key functionality features, and now we'll be open for a Q&A section. So again, if you have any questions and you have not typed those into the Q&A box yet, you can type those in now, and you'll be answering now. Okay, so the first question here, can you provide a sample application that used the custom widgets you presented? I can. We can definitely, I'll get your information after the meeting here, and we can put something together, and we can definitely share that with you. Also is asking about what version of InduSoft Web Studio we were using to develop this application. So we developed this application with our newest release of InduSoft Web Studio, so version 8.0, and we are releasing a new patch with new functionality this Friday, patch 2 as well. Roberto, one question here more to you, asking about what are the sampling rates for the energies, for the meters that we have on campus?
Oh, yeah. I mean, it's real-time data. So we get meter information, and it's immediately computed into and converted into energy data. Then it's integrated every second. So it's real-time data.
Thank you. Okay, another question regarding more the estimating clients, about the support for estimating clients. So the estimating client is a solution, is a functionality that we've been developing. We first introduced that in version 7.1, and we've been enhancing and improving this solution since then. On version 8.0, we introduced several new features like support for MDI, so multiple document interface, so pretty much the ability to have several screens open at the same time. So we are growing this solution every new release, and since the release of version 8.0, we are seeing some very nice use from our customers. So, yeah. Okay, another one, I think that can be for both, but what protocol do the smart meters have and how these integrate with InduSoft? Do you want to answer that one, Roberto, or?
Sure. So we have the the smart meters are IONS 8650. It's a Schneider product, and we bring data from them Modbus OPC TCP/IP, and then they get into our OPC server, which is a Kepler server, and then we InduSoft post the data via an SQL database.
Okay, great. Thank you, Roberto. Another question here, do they have any alarms sent out from InduSoft for their system? Yes. And Roberto can complete if you want here, but yeah, we do send out alarms, even emails, whenever there is a meter fail, for instance, if we're not able to communicate or something's wrong with the meter, we send out alerts to the maintenance people to help them to have a faster solution. Okay, let's see what else we have here. Okay, another question regarding the support for custom widgets. So this is a new solution that we are introducing to our product. It's not 100% integrated yet. So what we have is several companies, we have several companies working together with our consulting services teams to develop their solution, develop their application, being trained on this new solution. So if you have any interest on that, feel free to contact us, and we'll be more than happy to assist you use this new solution. Okay, another question here. Is InduSoft collecting data? Yes, we do collect some of the data that we use for the energy analysis. As we said, as Roberto mentioned, everything goes through a central OPC, and from there goes to a historian. But especially for the energy analysis, we are receiving data through this OPC, and we are storing this data into SQL so that we can run our performances, regression analysis, and so on and so forth. Okay, another question I haven't noticed. Do you also monitor water meters in the campus? Roberto, do you want to take that one?
Yes, we have a pretty strong water, water reduction initiative, and we monitor water consumption in campus. Is one of the items under sustainability. I don't know that we got the chance to look at it, but yes, we have plenty of water meters, domestic water meters, and irrigation meters that we get data from, and we do trending with them, and we're able to reduce water consumption that way. People is looking at water consumption a lot. So yes.
Thank you, Roberto. Another question here regarding when do they can have this recording of this webinar. So we have all the recordings of our webinar on InduSoft.com under support, video library, webinars. So you can come here. Probably either today afternoon, if not tomorrow, you have this webinar posted and you can watch or even download this webinar for your later reference. Okay, another one. What type of water smart meters were used? Our data in kilowatt-hour and trained by InduSoft. So, Roberto, do you want to answer the part for the
they're Ion 8600, 8650. They're an Eaton Schneider product. So we use those, and we bring KW data. We bring KWH data as well. So we bring demand and consumption together. The KW data is brought into the PLC so that we are consistent on how we integrate the data. And the KW demand is sent directly to InduSoft for display and trending. The KWH is sent to our PLC, computed, then sent through the OPC into InduSoft.
Thank you, Roberto. Okay. I don't think we have any more questions here. So, and we are also running out of time here. So again, I want to thank you, each one of you guys for taking the time to watch the presentation today, and especially Roberto for taking the time to putting together this very nice and detailed presentation about the University of Texas here in Austin energy efforts. And talk to you on the next webinar. Thank you. Bye-bye.
Thank you.